Thank you for coming another Friday to the seminar. Today we have Diego Fansa, who is working in the Mares group with Jorge Terrados, and he's going to present his proposal for obtaining the master's degree. So thank you very much for coming, and thank you, Diego. Your turn.
Well, good morning, everyone. Thank you all for coming. As Jessica said, I'm going to present my master's thesis, which was supervised by Jorge Terrados and Fansa, and belonged to the universities of Alcalá, Complutense, Politécnica, and Juan Carlos from Madrid. The name of the master's is Ecosystem Restoration, so it's mainly about that. This thesis was called Short-Term Density Independent Survivorship of Posidonia oceanica seedlings within a restoration project in Northern Mallorca. So let's go for it. These are the contents of the presentation, and as you can see, they are very similar to a regular scientific paper or a thesis. Well, just to give you a bit of context, I guess that some of you, or most of you, have heard of Posidonia oceanica, but it's one of the 4 species of seagrass that we have here in the Mediterranean Sea. It's endemic of this place, so it's the only sea where you can actually find it, and it has a depth limit at 40 meters. That depends on the transparency of the waters. So, for example, here in Mallorca, we have meadows really deep, around that depth even. But for example, if you go to the Catalonian coast, where the water is less transparent, is more turbid, you would find it maybe at maximum of around 25 meters. It's very important for many reasons, but because it provides a lot of ecosystemic services such as carbon storage, habitat creator for numerous species of fish and invertebrates, and well, also protecting the coast, mitigating the wave energy. However, since the 60s, it has suffered a regression in their cover area from 13 to 50%, depending on the place of the Mediterranean, due to human impacts mainly, such as water quality degradation, coastal modification, or for example, mechanical damage, which is one of the main factors here in Mallorca. That, well, as you know, there are many boats, and the anchors, the chains that are attached to the anchors have caused a lot of damage of regression here in our populations. So because of these factors, Posidonia oceanica has experimented some restoration projects in order to conserve and to restore these populations. And to give you a little background, I found this paper from Fansa et al., where they did a huge review of all the papers, and we appreciated that even though the restoration started around the 70s, in the decade of the 70s, most papers, or at least the amount of papers per year, has increased a lot since the 2010, especially in the Western Mediterranean, in countries like Italy, France, or here in Spain. There are some factors that change from one project to the other, many different scales. One of them is the depth. As you can see here, most experiments have been done in medium depths with different levels of success. Also, we tested different substrates that we have to differentiate between consolidated substrates, such as hard rocky substrates or dead matter, and then soft substrates like sand. Just to explain you for people who don't know, the matter is a French denomination that is used for the mix of, it's a consolidated substrate, but it's a mix of sand with then remainings or debris of an older Posidonia oceanica meadow that existed in the past. So all these dead parts mixed with the gravel, the sand, they create a very consolidated, rough and complex substrate that's actually very good for restoration purposes. And then as you can see, in most restoration projects in soft substrates were not very successful. Then we also have the type of planting material that is used for different projects, especially differentiating between rhizomes and seedlings. The orthotropic rhizomes are the ones that are usually growing vertically, and then the plagiotropic are the ones which are responsible of the main growth of the meadow because they have faster growth rates and they grow horizontally. As you can see, there are just a few, there are not many projects that have used seedlings, just around 25% of them, although they have been very successful. In this project, we use seedlings, so I'm going to explain a little bit more about restoration with this material. So, well, this Posidonia oceanica is a phanerogam. It's a plant that creates flowers and fruits. But these flowering events don't happen every year. So from time to time, we still don't know the factors that are triggering these events, but they are very scarce, they are unpredictable. So from time to time, they happen. For example, there was a very strong flowering event in the autumn of 2022, recently, that generated a lot of fruits that were actually used in 2023 for the experiment. So the flowers, they create fruits that look like an olive, and they are positively buoyant. These fruits end up on the beach, where you can sometimes see them. They are like little olives, and each one of these have a single seed. So these are the seeds that we use for restoration purposes, although they need to be usually cultured in controlled conditions before planting, because we need them to develop a root system for at least more or less 2 months, or at least 2 months, in order to look like this. So this is already a seedling that is prepared for planting. Well, this is a picture from Project Bosque Marino that has been planted. So what are the main strengths, the main advantages of this method compared to using fragments? Is the fact that we are fostering genetic variability, because, for example, right now there are new genotypes, we're discovering new genotypes of Posidonia that, because of the rising sea temperature, they are getting more resilient, more resistant to these well, heat waves. It's important, I guess, I believe, to use them for the future experiments. Also because of these seedlings, eventually in the future, because they grow very slow, but in the future will generate new meadows, so they contribute to population dynamics. On the other hand, there are some weaknesses as well. There are some disadvantages. One of them, as I said before, that the fruit production is very scarce, it's unpredictable. So we can't actually count on seedlings every year, so just whenever they come. And also that the seedling establishment is a very sensitive phase, because as you can see, it's a small plant, and sometimes they develop a longer root system, but sometimes they don't, as you will see. So this first phase is really sensitive, and even when natural recruitment happens, it's been tested that it's been recorded that it's not a very successful phase. We also had a look at some ecological interaction that I want to talk about. In this case, interspecific interactions and intraspecific interactions. First, talking about interspecific between seagrasses. There are some processes happening every year on these ecosystems, and the main one that people have studied is the competition. So not just between seagrasses, but also between macroalgae like seaweed and seagrasses, that they compete for nutrients, for resources, for light, for many things. But it's also been tested that sometimes it might be a facilitation effect from macroalgae to plants, to phanerogams, from phanerogams to algae. So that also actually happens too. And especially, for example, after a disturbance, when there's a disturbance happening in the seabed, in this kind of ecosystem, pioneer species, such as Timothy that we have here as well, which is a small species, it has a very fast growth rates. They colonize the habitat, kind of changing and creating the proper conditions for that other species eventually later, such as Posidonia oceanica, colonize the habitat and sometimes outcompete these pioneer species, but sometimes they even coexist. And we know we have records of mixed meadows of Timothy and Posidonia oceanica, and even with other seagrass species too. And on the other hand, talking about intraspecific interactions, looking at the meadows, we know that they're very dense. The mature meadows, they can get really, really dense. Sometimes you can even see the substrate. So we were wondering if it would be better to have a denser seedling level, or something intermediate, or something lower. And apparently, according to the scientific literature, the intermediate densities work the best in the few cases that they use them, although there's a lot of research to be done about this, because there's not a lot of information in terms of restoration purposes with seedlings. So now let me explain you the goals, the main objectives of our experiment. We wanted to test short-term seedling survivorship, just 3 and 6 months after the plantation, under these two scenarios. So first, we had what we wanted to test 5 different density levels from a very low density, 25 seedlings per square meter, to 400, which was the most dense level. And then we also wanted to have this scenario of a pioneering species to see if this species would facilitate the survivorship of the seedlings. So we had both the presence and the absence of the species. So let's go with the material methods. This was our study area. We were in the north of Mallorca, in Pollensa Bay, where we had 2 different locations, Bosque Marino and Esbarcares. So they were on one side of the bay, but we realized that the conditions, like geographical conditions, were similar because it's just a semi-closed bay. And the difference, main difference were, well, not that much the depth, because they are just 1 meter different. This is the average depth of each one of the locations. And then the substrate that we found in each one. So in Bosque Marino, we had dead matter. This is the substrate that I explained you before, more consolidated one. And then on the other side, we had sand, which is an unconsolidated substrate. So we wanted to know how these different substrates would affect the survivorship. Also, the seedlings were cultured in controlled conditions here at the media for around 3-4 months before being planted. And then also before planting them, we measured, as you can see in the picture, the leaf area, also the seed size, the root system, to know our different subsets of seedlings, if they were actually different. We'll see in the results if they were different or they were very similar, because we planted some here, another here, some here. So just to make a very quick review, to make it very clear, this is the experimental design. We are in Pollensa Bay. We have 2 different locations, okay, one side of the bay and the other side. We wanted to test interspecific and interspecific interaction. But in Bosque Marino, we just had this subset with marine phanerogams. We were trying to find the subset without the presence of the marine phanerogams, but we could not find it. So we just had that one. Whereas in Esbarcares, we actually had the sand without anything, the bare sand, and then covered by marine phanerogams. I'm mentioning here marine phanerogams instead of Timothy nodosa, because eventually when we were planting, we also found another species of seagrass, which was Postera nolte. So at the end, we had that category because we were like considering the effect of both seagrass, not just Timothy, but also Postera nolte. And basically on each one of these 3 substrates, we planted 10 replicates, which correspond, each one of the replicates correspond to these 5 density levels. Okay, so then this number is the amount of seedlings on each small plot, which correspond to these density levels that per square meter that I explained before. Also, in parallel with the planting process, we measured some variables of the meadows, not to relate the density or the size of the meadows to the survivorship, just to have a general understanding of the size of our meadows. Okay, so we got some, we measured some variables like these ones, and also collected some shoots to find out about their leaf biomass and leaf area index, that are some variables to understand their traits. And well, we did the plantation in September 2023, and then 2 monitors, as I said, the first one in December, 3 months after the plantation, and the second one in March. So you can see in these pictures, sometimes we would find some seedlings alive, and sometimes there was just the bare substance without any seedlings. This does not really mean that they were dead; they were just uprooted, so they were somewhere else. But of course, if they can't anchor to the substrate, eventually they would die. So we counted this as dead. Okay, so let's go with the results. This first table, it's the seedlings phenological features of each one of the subsets of Bosque Marino and Esbarcares. So in terms of the leaf area, the leaf section, they had similar values. They were actually, we performed a statistical analysis, and they were not statistically different in terms of the leaf section. Just that this variable was different, but it wasn't very important in this case. Because you can see, for example, the leaf area per seedling was very similar. However, the root length, the root system, was actually very different between one and the other, and we even found statistically different pools of seedlings. So you can see Esbarcares subset had total root length per seedling and also higher average root length. About the general seagrass characterization that I mentioned before, the main conclusions were that we found similar shoot densities in October. This was done in October. And as you can see in Sbarcares, we also found Fostera nolte. That is usually it's a smaller seagrass. We also found less shoots per square meter. So you wouldn't imagine a very strong effect from it, but you can also consider it. Nevertheless, we also found a significantly larger meadow in Sbarcares. So the densities were similar, but the size of the shoots were way bigger, as you can see, for example, with the biomass in Sbarcares compared to the meadow in Bosque Marino. And then that we appreciated also a decline from October to March in most of the species, but that's just because of normal seasonal changes. They have a maximum in summer and then a minimum in winter. Okay, so this was the survivorship that we found. Here, let me explain you the graph. The dark green is the monitoring in December, the first monitoring after 3 months. And as you can see, I don't know if you can read it properly, but the highest survivorship was found in dead matting, the consolidated substrate, around 60% of survivorship. Whereas in sand, it sat covered by phanerogams, we had around 42%. As you can see, we did not find any seedling alive whatsoever. So we want to do the statistical analysis that I will tell you later, but that would mean that the phanerogams have an effect. Then it was also important to see that there was no significant difference between the first and the second monitorings 3 months later, which means that these first 3 months after establishment is the critical phase of this process, because it's when the seedlings have the smaller root system, and so these 3 months are critical for the survivorship and development. And well, about the density assessment, I already did a bit of a spoiler in the title of the presentation, because indeed we did not find any relationship between the density levels and the survivorship on any of the substrates. So they were actually independent from this factor. Just to give you some ideas, in dead matting, the consolidated substrate, we found the maximum survivorship in the medium high density levels, so around 300 and 200 seedlings per square meter. Whereas, for example, in the other substrate, in sand with phanerogams, we found the same highest survivorship, around 50%, in the minimum density level and the maximum one. So that was a bit odd. We were maybe not expecting that, but that's what we found. And then there are no sand results because we did not find anything, so there was no survivorship at all. All right, so let's discuss these results. First, we noticed the importance of the substrate type. We found the highest survivorship in dead matter. We were actually expecting this because it's already been recorded many times that this substrate is the best one. In all of these papers, they had really high survivorships. So the roughness and the complexity of the substrate actually helps the seedlings to anchor and to establish. Whereas in unconsolidated substrate like sand, I don't know if you remember the first graph in the introduction where the projects in sand were not very successful. Well, it's basically because the high dynamism of this substrate, because of what moves and relocates all the time. So at the end, it's hard for the not just the seagrass, but also even the macroalgae to establish. It requires really a very strong roots. So we had also worse results. However, when this same substrate in the same location was covered with the phanerogams, we actually found some alive seedlings. After 6 months, we had a 40% survivorship, which is not that bad, I believe. And whereas, for example, after 3 months with no macrophytes at all, no seagrasses, we didn't have any survivorship. Why is this happening? Well, one of the reasons is that probably the rhizomes and the roots of the Thymolphea and the Fostera are consolidating the substrate, creating a kind of a network that helps the seedlings to anchor to the substrate, and so that's increasing the survivorship Also, because the leaf section, the leaf area of these seagrasses act as a wave mitigator because they can reduce the drag forces from the currents that affect the seedlings that can uproot the seedlings. So they could act as a protection for the seedlings. And then maybe there might be other effects that we did not test, but there are some papers that have tested interactions between not just between seagrasses, but also with macroalgae. For example, there's a paper of Briones et al. From 2018. They tested they did an experiment with Posidonia celica seedlings, but in the presence of other macroalgae, polioles and interested macroalgae, and they found that the seedlings survivorship and growth improved under the presence of these other macroalgae. And in fact, even with the presence of a non-native invasive species such as Pathylindratria, the survivorship was higher when this non-native species was present with the seedlings. So you actually never know if there is a competition or a facilitation effect. It depends on the interaction between species. So, okay, which factors were responsible of the seedling losses? As I said before, the first 3 months are very important because also were at the time that was at the end of the summer, at the beginning of the autumn, and as you know, here in Mallorca, the strongest storms happen here during this period of time. So we did not measure the survivorship the week or the day before and after the storms, but it's very likely that they were responsible of them. And as you can see here, this is a map of Bosque Marino plantation location. And we have this geographical feature, which is called Punta Avanzada, that protects a lot this area. So when there's, for example, many like high waves outside of the bay or outside of this area, this Punta Avanzada usually protects the plantation. So that maybe also helped for the successful survivorship of the seedlings. Also, it's been tested that in some papers that the consolidated substrate present higher resistance to wave speeds. For example, in Fansa et al. In a paper they did in 2011, they tested the wave resistance, the wave speed resistance of the seedlings when they were on sand, on unconsolidated substrate, and I think they measured around 18 centimeters per second. So as the resistance to wave speed. So over that speed, over 18, they would uproot. On the other hand, Fansa et al., they tested the same thing, but on a rock, on a consolidated substrate, and it required a speed of 87 centimeters per second, so way more on that substrate. Also, we did not develop a very large root system in the lab. Don't know exactly why, but they did not grow very, very much. And so that could also have been one of the reasons. I found this paper of Balestri et al. From 1998, and in the same substrate with way higher root lengths, they had an 83% of survivorship after 1 year. Although I also have to mention that they used an anchoring system for the seedlings, so that probably also helped for this high survivorship. But we don't know how much that affected or how much was the root length. But we really believe that this is obviously a main factor that you need to take in account in order to decide when to plant. You can't actually wait too much either, because if you wait too much and they grow too long, then it's also very difficult to plant them in the substrate. And then talking again about the density independent performance of the seedlings, as I said, we did not find any interaction on these circumstances, on this context, but as I mentioned before, the intermediate densities are supposed to show better results. In this paper from Balestri et al., for example, they had the best results at densities between 60 and 120 seedlings per square meter, which are a bit lower to the ones we had, but they had that. Also, this other paper, Balestri and Narvici, they found that very crowded clumps, over 800 seedlings per square meter, are not very good either, and they correlate to higher mortalities. So that's basically all. Let me give you these last conclusions, these 5 ideas that we obtained from this experiment. And we did not find observe any particular pattern of interaction between density levels in any of the substrates, but there's still a lot of research to be done with this. I think we did not find many papers about this, so we actually don't know if the conditions are different. Maybe we would have different results depending on the ecological interactions at different levels. And that the substrate type was, again, the most important factor for seedling establishment, being the mate, again, the best substrate, even though, I don't know if you remember, but it had significantly shorter roots than the ones planted in esbarcares sand. Also, that with the presence of marine phanerogams as Timothenodos and Posidonia enhanced, improved the survivorship in unconsolidated substrate like sand. So they showed a facilitation effect, or at least on unconsolidated substrate. It would have been nice to find dead matter without any macrophyte to test if even in a consolidated substrate also they facilitated, but we could not prove that. Then the main safety losses were probably related to storm events happening during this first autumn. I think that this is also very important because it gives you some insight of when to plant the seedlings. And of course, the natural process are that they flower in spring, then they in autumn, sorry, then the fruits arrive to the beaches around the spring, and the natural recruitment usually happens at this time of the year. But maybe in some cases, if you have a good root system, it would be perhaps good to plant in another point where there are not many storms, or at least to know if there's going to be some storms in this area where you want to plant. And last, that the higher survivorship would have been expected with longer root that we did not achieve. But we checked the literature, and there's like a correlation between the root system and the successful settlement of the seedlings. So that's all. Thank you for listening. And if you have any questions, I will be okay.
Do you think that the difference in the root length between the mate and the sand might have anything to do with the difficulty of growing into something that is more compacted, and maybe that could you could sort of prime the mate locally in such a way that maybe it makes it slightly easier for the seedlings to develop a slightly longer root system.
So, well, Laura, when she actually did some experiments in her thesis with this. She found out that when they were culturing seedlings in sand, they were growing better. Actually, they were like the sands because the sand is less consolidated. The seedlings had a lower resistance to grow vertically. So it's possible that they grow like longer or faster in sand because they don't find many obstacles like they could find, for example, in the dead matte, that they might find a Posidonia rhizome, which is very strong, so they can't overcome that one. But at the same time, they don't have anything consolidated or solid to anchor in the sand. So if there is a strong storm where the sand moves a lot, even though that they are long roots, they might move and they might relocate. Whereas in dead matte or in rock, there are these solid consolidated substrate where they can attach, and they can find the roots have these tiny little hairs that they can attach to the crevices of the rocks, or they can attach to the rhizomes and the remains the debris of the dead matte. So perhaps, yeah, they grow faster in sand, but they attach better, they settle better in a consolidated substrate. So it's like equilibrium. That's why you need to know if you're gonna have strong storms in the area where you are planting, because that's important to know, and also the substrate. So
but the fluidization of the sand will depend a lot on for example, the fluidization of the sand will depend a lot on the grain size, and so different sands are going to give you different.
Yeah, probably. If you have different textures of sand, you might have a different outcome. But still, it's a very volatile or moving substrate. So even if the grain is bigger or smaller, if it moves, and it might move the seedling as well. And once the seedling is a bit unburied, with the water, it can go away. So I guess there are some textures of sand that work better, Because in every, as you say, in every place it's different, but yeah, that's what I think that happens.
Yes, thank you and congratulations on that. Did you notice any effects to the other species after the 6 months of the seedling?
Not really, no, we did not measure in terms of, so we did I didn't include it in the presentation, but because we did a net size variation assessment, so we actually measured okay, you were saying to the other species, like the other species like presented lower sizes after the plantation, but that's because of the natural seasonal change of the species. So I guess we will need to go again now in summer and see if there are some changes. Actually, that's the kind of the problem with this. Maybe this experiment, it was in a short term, so you would need to know what happens after maybe 1 year or 2 years. But in this short term, I don't think they affect that much. But it's possible that also the roots of the seedlings might also help the Hemophaea and the Zostera to establish or to have to settle in the substrate way better. Of course, they are more prepared to be in the sun than because of the root architecture of the system and everything. But we didn't measure that. But it's possible that the seedlings also helped the Hemophaea shoots to establish and to stay longer term. Yeah, because the facilitation effect can be mutualistic, right? Like can go any direction. We found that at least for the Posidonia seedlings, it was positive. The other way around, we didn't measure it, but I think it's possible. We would need to check maybe in 3 more months and see what happens. Yeah.
Do you have an idea of the natural mortality of seedlings?
Sorry?
The natural mortality, I mean, if you follow.
Yeah, natural mortality, but not of this, like you mean.
No, that's right, I mean, of the species.
Yeah, the natural, I don't know the exact value, but I know that the natural recruitment is very low. So the natural process that these seedlings experiment, because there are sometimes when there's a flowering event, especially when it's very strong, and many fruits are produced, first, so the fruits that end up on the beach are the ones that didn't open. So once they open and the seedling drops from the seed, is actually negatively buoyant, so it sinks and it goes to the substrate, and wherever any place where it arrived, it's the position they have to fight and they have to develop. But because of the natural recruitments are very low, that's for sure, and that's been tested, and so normally the mortality rates are very high. Also because of the same thing, once they drop, once they're in the seabed, the root system is not developed. So most of them are wandering around and they move to one place to the other, and just a few of them can successfully establish on the substrate and develop the root system. Once they are enrooted, the roots start growing very fast, way faster than the leaves. So once they are settled in the substrate, then they can actually survive. But that's the problem, like these first months that they need to fight against the storm, they need to fight. So depending on where they end up, that's also where the importance of the location.
Because your 3 months mortality, you say it was 30% or something like that.
Yeah.
It may be natural mortality due to the quality. So
the natural mortality, I'm pretty sure that is way higher than this. It's way higher than the one we had. Yeah. So yeah, of course, because
on top of your experiment, an effort of individual quality.
Yeah, we did not. At least I did not. Maybe someone has done something with this, but yeah.
No, because it's similar to many reproduction plans in also on animals. You got a very high mortality in the first month. Where was the keeping condition? You know, you release the animals, and then the first month already 20%.
Yeah, that's why it's the most sensitive phase, and the one you want to control. Once they are established, then usually thrive and survive.
I would like to ask something, just following that I'm not checking. Is September the best month to plant this?
I mean, so in nature, this is what usually happens because, as I said, you have the flowering event in autumn, right? From maybe August to November. Then the fruit production in spring, so around, I don't know, depending on the year it changes, but April, May, you can find the fruits on the beach, for example, if you see them. And then they, from this point that the fruit opens and the seed goes to the seedbed, it requires at least like few months for the root system to develop. So this is what actually happens, like the natural cycle of the species is they establish at this point of the year. It's true that maybe in some locations it might not be the most adequate one, but if you get the fruits in, for example, in May, around this, if you plant them at this point of the year, that you think, okay, we can plant them now because there are not many storms. It's the spring, it's the beginning of the summer, so it's good that we're gonna have a good weather. But the roots are really small. So even though you don't have big storms, that any tiny disturbance might affect them. So you have to wait for the root system to develop, and that's why you culture them in controlled conditions, because you can kind of control how they develop and how they choose the moment that they have the best root system and then plant them. But yeah, it's a pity that sometimes it's the same moment where the storms happen. But yeah, it's what it is.
More questions? So we can leave it here. Thank you very much.